Thanks a lot for the introduction. It's great to be here. Good morning. Thanks for all coming in so early. So my talk is about how to win developers' hearts with highly productive tools that people like to use. So to introduce myself a little bit further, so I work at Google, mostly on the TensorFlow machine learning platform. And on the side, I do a little bit of AI research. So my main research interest is understanding abstraction in the human mind, so that we can create artificial minds capable of artificial abstraction. And 4 years ago, I started Keras, so this deep learning library. So we just celebrated the 4th birthday of Keras 2 weeks ago. And it's grown quite a bit in the past 4 years. We just crossed 350,000 users. So that's a big chunk of everyone doing deep learning, roughly 40%. And this talk is about what I do. So not about Keras directly, not even about deep learning or data science directly. It's about really how you can leverage best practices to create developer tools. They could be data science tools. They could be, any kind of developer tool really, that will be productive, that will be delightful to use, and that people will just like. So you're all data scientists and programmers, so you all use lots of tools with funny names, like Conda or Kubernetes or Hadoop and Keras. Maybe not Snorlax, because Snorlax is a Pokemon. And so you all know how important, how critical our tools are to our productivity and our happiness. And the thing is, a lot of the time, our tools are just not very good. They let us down. They leave us, Googling some obscure error message that's completely cryptic that you really, cannot decipher. Or they leave us, searching Stack Overflow for how to use this undocumented function that's, so important to your current workflow. So yeah, often our tools just let us down. Our tools have a lot of potential to cause us pain, especially in a field that's so complex, so complicated as software engineering and data science. So developer user experience is a critical factor of success. It's a critical factor of success for the people who are going to be using your code. But it's also a critical factor of success for yourself. If you create any kind of reusable piece of code that someone else is gonna try to work with, this is going to be extremely important. And shockingly, UX design, which is a thing, right? UX design is usually not a concern when people create developer tools, like programming languages, libraries, and so on. So people just maybe don't care about it or don't know about it. And I'm really here to make sure that you will all know about it and care about it. This is really a topic I spent a lot of time thinking about. I'm very emotional about programming interfaces and developer UX. So the programming languages and libraries and frameworks that we use, they're not just meant to be executed by computers. They have users. There are humans in the loop. And if they have users, then they have a user experience. And that user experience is critical. So this talk is all about a few very simple best practices you can follow. Because like most things in life, building great tools is not actually difficult. It's not some kind of magical trick. It's all about following very simple rules, best practices. So I spent a lot of time thinking about these things, and I've developed 3 very simple rules that I'm going to go over. So not actually 3 rules. It's just one rule. One rule is going to be easier to memorize. So one core overarching principle. And the 3 rules I was mentioning are just directly derived from it. So it's just one secret. And the secret is this. Every design decision that you make should be made with the user in mind. So you should care about your users, about all of your users, not just about the smart users, not just about the experts, not just about yourself. You should really care about all of your users. So that sounds obvious, right? I mean, if you're going to create a library that's going to have users, then of course you should create it with the user in mind. It sounds obvious. But shockingly, it seems that this is actually kind of a superpower. Keeping the user in mind is a kind of superpower. It will enable you to do, to create much better tools. And very few developers of software tools actually keep this in mind. So my 3 rules are this. First, deliberately design end-to-end workflows focused on what users care about. And then in the end-to-end workflows that you've developed, make sure to minimize cognitive load. And finally, it's about providing helpful feedbacks for users. Things like the error messages that you run into in the course of debugging code, or things like documentation and so on, FAQs and so on. So let's go over what they mean in practice. So the first rule is designing end-to-end workflows focused on what users care about. So you have really 2 parts, end-to-end workflows, what users care about. So what does it mean to design end-to-end workflows? Well, a lot of the time, libraries and frameworks are not really designed as these like consistent, holistic workflows. They're more designed as a set of atomic capabilities that do not necessarily fit well with each other. Think about, think about if the people who created scikit-learn, if they had created it where data preprocessing and model training and model scoring were all like designed, developed by separate people with no concern about how they fit together, right? Well, that would be a terrible framework. So thankfully, scikit-learn is actually a great framework. It's very well designed. And a big part of why it's so well designed is because in scikit-learn you have this very nice and consistent and coherent end-to-end workflows. Everything just fits well together. But for most libraries, that is not true. So this is really a trap that you should not fall into. And in order not to fall into this trap, whenever you design a new library, any kind of tool that other people are going to be relying on, you should start by writing down the steps end-to-end that your users are going to be going through and identify pain points, and then just iron out the pain points ruthlessly. So make sure everything fits well together. Don't just design atomic functions and method providing capabilities in isolation. Just look at the big picture. And the end-to-end workflows that you design should be all about domain-specific concepts that users are familiar with. Like imagine if you're at a restaurant and you order a burger, and the waiter asks you, so what sort of grill model do you want us to use to cook your burger? What should be the temperature on the grill? How long do you want us to cook your burger? Well, these are not the right questions to ask. A lot of the time, the APIs we use are really designed from the perspective of the implementer. So that's what I call checkbox-driven APIs. The implementer of the API had a set of constraints they needed to satisfy, a set of checkboxes. And the implementer will then proceed to write something in this very self-centered perspective, where they're essentially dumping all of the complexity on the user. The implementer is asking the user for information that is only relevant to the implementer, right? Like a waiter asking you what grill model should we use to cook your burger. So there are really 2 mindsets when you're designing APIs. One is really this implementer mindset that's very constraint-driven. And the other mindset is user-centric. So you put yourself into the user's shoes. Instead of asking, as the implementer, what do I need to know? You're asking, what does the user care about? What does the user want to tell me? So in the case of this burger cooking API, the user wants to be able to specify, I want my burger medium rare, right? So that's what the API should be about, not about the low-level implementation details. So checkbox-driven APIs are really all about how things work under the hood, which are things that are not actually relevant to the end users. So for instance, if you're writing a deep learning library, maybe it's going to feature concepts like session, buffer, param group, blah, 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 none of this is about deep learning and data science. These are all about internal implementation choices made by the implementer. So if you're exposing APIs like this, you're actually dumping a lot of unnecessary complexity on the user. These are not good APIs. These are really all about the constraints that the implementer has to work with. This is a very self-centered way of writing developer tools. So the opposite of that is really user-centric design, where every concept in your API maps to a user that an action that the user wants to take, so domain-specific concepts. So if you're writing a deep learning API, for instance, you're going to feature objects like layers, models, optimizers, and so on, because these are the objects that users want to work with, not sessions and buffers and so on, because these are not deep learning concepts. So what do you think of this API? Is this checkbox-driven, or is this user-centric? So from my perspective, I know about deep learning, I know about machine learning, but when I'm reading this, I have no idea what any of this is about. All of this is about, essentially, the internal implementation choices made by the implementer. This should not be user-facing, right? So the first rule was design end-to-end workflows that are all about what your users care about. And the second rule is, in these end-to-end workflows, you should seek to minimize cognitive load. So you should seek to make things simple. It's always about the user and making it easy for the user. So the thing with good software is good software makes hard things easy, makes hard things simple, right? If you look at well-designed libraries like scikit-learn or Redis, what they do is actually very difficult. They solve hard problems, but they don't make it hard on the user. They make it really nice and easy. Things like model.fit, which is a scikit-learn workflow initially, right? And the reverse of that is bad software. Bad software makes easy things hard, right? Like uncompressing a tar file. How difficult should this be? It's literally impossible to do it for normal people without looking up the command every single time, right? And by the way, so there's actually a mistake with this command. It's not tar-xvzkf, it's tar-xvzf. You've probably noticed this. So how do you make things simple? How do you make hard things simple? Well, the first thing you should do is automate everything that can be automated, right? So reducing cognitive load is all about minimizing the number of user actions that are necessary to go from point A to point B. Essentially, figuring out what the user wants to achieve and then basically paving the road ahead of them, right? So essentially, minimizing the amount of user actions, minimizing the amount of user input. Let's say, for instance, you're writing a deep learning API. There are lots of things that you should be automating. For instance, you should definitely be automating static shape inference. Like if you have a layer with a certain shape in entry, it should have a certain output shape. This is something that, as the framework implementer, you can compute on your own. You should not leave that for the user to compute, because then the user ends up doing a lot of mental math that's just not necessary. So seek to have workflows where you have a small number of steps, and the steps, are simple to remember. So again, low cognitive load, are consistent and intuitive. And another thing you can do to make hard things simple is provide approachable interfaces that are easy to remember. So naming is super important in software, because software, as I was saying, software is not just meant to be executed by computers. Software has users. Software is communication, can be communication across a team, communication with your users. So naming is a critical part of this communication process. So naming choices, there are only two hard problems in computer science. One is naming things, and the other is cache invalidation. So naming things, super important. Naming consistency, first of all, it means internal naming consistency. So if you have a concept that in one place you're naming access, well, you should always be naming it access. You should not suddenly switch to dim or dim_I in a different place. But it's also not just internal naming consistency, but naming consistency with well-established standards. So for instance, if you're writing a numerical computation library for Python, well, NumPy, obviously, is the standard. So as much as possible, you should seek to be consistent with the NumPy API. There's been this library released by a few folks at Google the other day. It's called JAX. It's pretty much an extension of the NumPy API. It's a re-implementation and extension of the NumPy API. It's great. It's great because it doesn't try to reinvent the wheel. It stays consistent with well-established conventions. So the first line here is the NumPy sum function. So you have this axis argument, you have this keep_dims argument, and so axis is a pretty good choice because it's consistent with the way domain experts would refer to this concept. This is an axis in a multidimensional array. Keep_dims is kind of arbitrary, but whatever, NumPy is the standard, so there's some freedom to make arbitrary decisions. And the line below is a much more recent numerical computation library. So what's wrong with it? Well, two things. First of all, it's arbitrarily deciding to rename axis to dim, which breaks NumPy conventions, but also breaks conventions with regard to how experts refer to these things. And for no good reason, like it would not have cost anything to just name this argument access. And there's also a keep_dim argument. Clearly, it must come from NumPy, because keep_dim seems close enough. But somehow, it manages to break the NumPy convention in a really annoying way, because there's no S at the end. So again, use internally consistent naming conventions, but also naming conventions that are consistent with broadly established standards. So before you name things, make sure to check how other people in other libraries are referring to these things, and make sure you check how domain experts are referring to these things. And a last critical part of reducing cognitive load is introducing as few new concepts as possible. So cognitive load, a big part of it is, as a user of a software library, when you're working with it, sometimes you're working with docs and so on, tutorials, but a lot of the time you've just internalized some kind of mental model of how it works, right? So you have this mental representation in your head that you're using to make decisions. And minimizing cognitive load, a big part of it is about making sure that this mental model is something you can easily convey to users, and that this mental model is simple. And it does not involve new ideas. So it stays very close to the mental models that would have been used by domain experts. For instance, if you're writing a deep learning library, the mental models that are necessary to use your software should be mental models from the field of deep learning and data science. You should seek to avoid introducing brand new implementation-specific concepts, like graphs, for instance, and sessions. And there's a litmus test that you can use if you want to know whether you've done a good job designing a library. So when you create something new, you should definitely be doing user testing. You know this, right? You should sit down with your users and look at how they approach what you've just written, right? And if there's something wrong, you should go back and iterate on it. So when I sit down with users, this is what I'm looking for. I think if a workflow is well designed, if an API is well designed, then it should be possible for a user to one day go through it once using a tutorial, like following some documentation, and then the next day come back, sit down, and go through the same workflow, but without any tutorial or documentation. So go through the same workflow from memory. A well-designed workflow, a well-designed API is an API where the cognitive load is so low that you can just learn it in one shot right? And so this gives you actually, this is very actionable, this is very practical. You can always sit down with users and see how long it takes them to memorize a workflow. This gives you a very concrete measure of cognitive load, right? It's not personal preference, it's not an abstract thing, it's something you can actually measure. And the opposite of this, an example of an API that fails this litmus test, would be the tar uncompressed command we saw earlier, because this is a very simple action, and every time you want to do it, you have to look it up. So it's the very opposite of that, right? And again, a big part of why this is not a good API is boils down to what we covered, things like having good names, for instance. So the first rule was you should be designing these end-to-end workflows as opposed to atomic capabilities, and you should make them all about what users care about. The second rule was in these end-to-end workflows, you should do everything you can to minimize cognitive load, to make things automated and simple and nice. And the third rule is about feedback, providing helpful feedback to your users. Good design is interactive. Good design is how it works, the user experience, not just how it looks like, not just what the signatures look like in your API, but how these functions actually behave in practice, what the debugging experience is like, and so on. And good feedback has mostly two aspects. There's documentation, and there are error messages. So first of all, if you want your software to give good feedback to its users, you should be ready to receive feedback yourself. So you should make sure you have a place where users can ask questions about this new piece of software you've just released. If it's going to be used just internally by your team, it can be an internal Slack channel or something, maybe a mailing list if you're at a very large company. But make sure you are listening to your users. Make sure you are in touch with your users, that you have visibility into the experience that they are going through. If you're not in touch with your users, there is no way you're going to be able to write software that puts the user at the center, that puts the user in focus. So be in touch with your users. This is really the most important thing. So the first part of providing good feedback is documentation. Documentation is not an add-on. It's not something that's not like an afterthought that you slap onto a software tool after you've created it. It's a critical part of the user experience. Because when you work with a library, a lot of the time you spend is not time writing code. It's actually time reading tutorials and reading docs. So anything that the user is spending time on is part of the user experience. So do invest in high quality documentation. This is important. I promise you, if you do this, you will see higher return than just focusing on developing more features. So if you don't have good docs, you should drop everything and just go write more docs. And the second thing is about error messages. A lot of the time we spend working with libraries, so it can be reading tutorials, reading docs, sometimes it's writing code, but then a lot of the time is actually just debugging the code you've just written. So the error messages, again, are not an add-on. They are not like a side thing. They are an essential part of the experience that your users are going through. So the first thing you should be doing is anticipate what sort of mistakes people are going to make, and you should catch them early and catch them with very nice and helpful error messages. Right? And the only way you're going to be able to do this is if you are in touch with your users, if you're listening to their feedback, if you have some way to gain visibility into what they're going through. And again, user testing. So of course, reading issues on GitHub and Stack Overflow is a great way to gain visibility, but user testing is even better. You should absolutely sit down with your users and see how they approach your software. And error messages should be helpful. Like, you don't want to run into an error message like that, like unable to determine unknown property. Please specify an unknown property. This is not very helpful. This is, in fact, so not helpful that you cannot even Google it, right? You cannot search Stack Overflow for it. So if you see this in the process of debugging your code, you're just completely lost. So a good error message should answer three things. First, it should provide context, like what just happened, where. And then it should specify the expectations of the software. Why was that a mistake? And lastly, it should be actionable. It should give you at least tips or even literally steps about how the user can fix it. So let's look at this practical example. You have two arrays of binary values, and you're applying this categorical cross-entropy function to them. So there's actually a problem here. This is the worst error message you could be doing. Checking user input with an assert statement. Assertion error 1 is not 2, indeed. You cannot even Google this. You cannot search Stack Overflow for it. So this is completely useless. Does not give you context. Does not give you what went wrong. Does not give you any help for how to fix it. Right? So first rule is when writing error messages, never use assert statements. Assert statements belong in unit tests. They do not belong in user-facing code. Always try to raise value error. And this will force you to have to spell out an error message. So this is a slightly better error message. At least it's giving you some context. It's telling you what went wrong. Invalid target shape. OK. What it's missing is it's not telling you why the framework thought this was an invalid target shape. So it's not telling you the expectations of the framework. It's giving you context, but it's missing framework expectations. And it's not giving you tips for how to fix it. So it's not very actionable. Here's a slightly better error message still. It gives you context, tells you what went wrong, and it tells you about framework expectations. So if you're reading something like this, you can actually start thinking about how to fix it. You can Google this error message, find something on Stack Overflow, and so on. But the best error messages, like typically your debugging workflow is like, you run into this, and you're not really sure what it means, so you just copy and paste it into Google, find something, an answer on Stack Overflow that will give you steps to resolve it. But the very best error messages are error messages that actually handle that whole process, right? Where you don't even have to Google them because they're already giving you the steps to resolve them. So this is a fairly verbose error message, but it's doing everything right in the sense that the first sentence gives you context. What happened? The second sentence gives you expectations. Why was it wrong? What did we expect? The third sentence, this is the most important, gives you what are your options to fix this? What are the steps you can take? And this is important because, so going back a slide, yeah. Yeah, so going back one slide, if you see this error message, it's kind of ambiguous. Sure, you have some pretty good idea what went wrong. You can start fixing it, but you're not sure if the problem is with the shape of your targets, or if the problem is actually with using the categorical cross-entropy function. So with an error message like this, you actually know what your options are. You could switch from categorical cross-entropy to sparse categorical cross-entropy, which seems to match your current shapes. Or you could just, reshape your targets. And so this kind of error message actually helps people, right? And if you think about it, if your framework just provides good error messages, then that's one less issue to get, multiplied by how many times people are going to be running into the same issue, right? So a good error message is like a self-resolving issue. And honestly, having the solution directly in your console is a much better experience than having to copy and paste the error message into Google and then find the resolution steps on Stack Overflow. So this is the end of my talk. So remember, every decision you make, every design decision you make should be made with the user in mind. And from this principle, we can derive 3 rules, which are very straightforward to apply. First rule is you should start by designing end-to-end workflows. So don't design the capabilities of your software in isolation. Actually look at the big picture. Design things that work well together. And these workflows should be all about what users care about. So they should be all about domain-specific concepts, right? They should not introduce, they should not expose internal implementation details to the user. Again, there are these 2 mindsets when you're writing software. One mindset is very implementer-centric, very self-centered, where you're like, what do I need from the user to make my life easier? And the other mindset is user-centric. You're like, what can I do for the user to make the user's life easier, right? What does the user want to tell me? And in these workflows, you should make everything as simple as it should be, but no simpler, right? It should still preserve expressivity and flexibility, but really automate everything you can, make sure the mental models underlying your workflows are simple and consistent, and that they're also consistent with the mental models of domain experts. And lastly, you should provide good feedback to your users. So that means good documentation, that means staying in touch with your users, having good visibility into what they're going through, and good error messages. And good error messages, again, provide you with what happened, some context, what did we expect, how you can fix it. And final thoughts, it really pays to do this. It's not just about making your users a bit more proactive and a bit more happy. It's actually about empowering your users to solve bigger problems, right? It's about empowering your users to win data science competitions or publish more papers, solve big scientific problems. Because solving hard problems like winning a data science competition on Kaggle, for instance, it's not really about being the smartest or having the best idea from the start. It's actually all about idea refinement. So you're starting with some idea that may be good, may be bad. You're going to come up with an experiment to test it. So you're going to implement your experiment. It's going to be a piece of code. You're going to run it on some very fast NVIDIA GPUs. Maybe you're going to be using NVIDIA Rapids or something. Then you're going to get some results. You're going to visualize and understand the results. And whether your experiment has failed or succeeded, you've learned something. And from what you've learned, you're going to come up with the next idea. It's going to be incrementally better than the previous one, right? And you get the best ideas, not by being the smartest, but by going through this loop of idea refinement as many times as possible, right? It's all about iterating. And what's critical here is the speed at which you can go through this loop. And good UX really enables you to minimize the time from idea to result, because it minimizes the time from idea to experiment. So if you have fast NVIDIA GPUs, you minimize the time from experiment to result. But if you have good software tools, you minimize the time from idea to experiment, right? And you see this in practice. So a few weeks ago, we ran a survey where we asked top competitors in Kaggle. So teams that finished in the top 5 of a competition on Kaggle over the past few years, we asked them what was the primary machine learning software tool they used. And Keras is actually the most commonly used library among top 5 teams, right? And I don't think that's just happenstance. I think that's really because Keras is just following these very simple best practices, and you can follow them too. It's not magic. It's actually just a very small set of rules. And by doing this, we are making it much easier to set up experiments. We're empowering users to try more things. And if they try more things, they're going to get better ideas. They're going to refine their ideas faster and further than other competitors, and they end up winning. So that's it for my talk. Thank you very much for listening.